Hey there. Let's start today looking at the Pythagorean Theorem. The Pythagorean Theorem is something you probably know the formula for, but let's practice actually using it. So the formula for the Pythagorean Theorem says that if you take one leg squared plus the other leg squared, it should equal the hypotenuse squared. But that's only if it's a right triangle. So this happens on right triangles that we would use this. All right, let's practice a few together, and then I'll turn you loose to do some on your own. I'll ask you some questions along the way. So on this next problem, when you look at it, the hypotenuse is always across from the right angle. So if the right angle is here, here is my hypotenuse. So I'm looking for the hypotenuse. When you do your Pythagorean theorem, the hypotenuse always has to be the C. It has to be the longest side. The hypotenuse is C. These are your two legs. All right, so let's try it. Let's go solve for the hypotenuse. So I'm going to take the first leg squared, doesn't matter which one, 7 squared, plus the other leg squared, so this happens to be a radical, which you might think is kind of messy, but we'll see, equals your hypotenuse squared. All right, you are going to definitely want a calculator for today's lesson because you're going to get some big numbers. The square and the square root just cancel each other out. So then in my calculator, I'm going to do 49 plus 65. I get 114. Now that's what x squared equals. I'm looking for just x, just this length, x. So I'm going to square root both sides at the end to undo that squaring. So x is equal to the square root of 114, and pay attention to the directions. They might want you to leave it as a radical. They might want you to reduce it. 114 actually is not going to reduce as a radical, but they might also want you to write it as a decimal. If I type in the square root of 114, I get a 10.7. This right here, these squiggly lines means approximately because I'm rounding it off. All right, so that's what I've got. So that's one scenario. The other scenario would be when they already gave you the hypotenuse. In this example over here, I know the hypotenuse and I'm looking for one of the other legs. I'm still going to use my Pythagorean theorem, but this time what I'm looking for is different. One of the legs is an 11, but I don't know the other leg, so I'll just call it x squared, but it's going to equal the hypotenuse squared. Right, 121 plus x squared equals 144. Now to solve for x, you're going to have to subtract that 121 to the other side. Try to get in the habit of doing some nice, showing some nice work. A lot of kids will just type this all in the calculator, and I suppose that's okay for some. But if you're watching this video, it might mean because you don't fully understand it, and so maybe showing some work would help. I get the square root of 23. That also is not going to reduce because 23 is prime. If I were to square root 23 in my calculator, I get 4.8. for that leg. Okay, so there's those two problems. I was supposed to ask you a question along the way. I forgot to do that. Okay, all right, let's move on. I'm going to have you do 2 of these by yourself. So here are 2 problems. In this first one, I'm looking for the leg. In the second one, I'm looking for the hypotenuse. So remember that the A and the B have to be the legs, and the C has to be the hypotenuse. Let's go ahead and start with this first one. Can you go find out what x equals? And I guess for the sake of the ed puzzle, it might be easiest if we go ahead and just put these in decimals. How'd you do? Did you get a 9.7 like me? Hopefully so. If not, take a minute to go ahead and pause the video and look at what my work was compared to your work. And again, that's one reason why you want to be able to show your work so that you can troubleshoot when something goes wrong. Okay, I'm going to go ahead and let you try, after you've troubleshot that one if you needed to, let's go ahead and try number 2 here. Can you go solve for x? If I went decimal, I ended up with a 15.6 on this. Hopefully you did as well. But what I wanted to point out is if the directions say to leave it as a radical, look at what happens on this one. Over here we had a square root of 95, and that does not reduce. But 244 is an even number. Seems pretty nice. I tried 4, and 4 did go into it 61 times. And then I looked at 61 and thought, well, that's not going to reduce any farther, so this is the best I could do. If they wanted it as an exact radical, you'd want to do this. If you leave it as a square root of 244, we'd probably take a half a point off for not reducing. All right, the next type of problem using the Pythagorean theorem was to decide if a triangle was right, acute, or obtuse. And in these scenarios, they went ahead and gave you all three sides of the triangle, but notice there's not a right angle here, there's not a right angle symbol, so I don't know for sure that it is a right triangle, but it kind of looks like it would be, but we're not really supposed to trust the picture. So if this was a right angle, then 12 would be my hypotenuse. So 12 is going to be the C. Plus 12 is the longest side. Remember, the hypotenuse is always the longest side. Your A and B could be, it doesn't matter which one's A and which one's B. All right, so our goal is to run this through the Pythagorean theorem and see if the Pythagorean theorem works. It only works on right triangles. So let's see if it'll work on this triangle. I have a 4 square root of 5 squared plus 8 squared, and this is really equals with a question mark, 12 squared. Does it equal that? I don't know. Okay, let's talk about squaring this 4 root 5. I don't know that this happens very often to us, so I'm not sure that you remember how to do that, but ultimately you're going to square both parts of this. You're going to square the 4, that's a 16, and then you're going to square the square root. The squaring and square root cancel each other out. So you end up with a 16 times a 5. That's 80. And this is a 64, and 12 squared is 144. And again, this is a question mark. Does it equal 144? It actually does equal 144. All right, so if I have a 144 equals 144, then it is a right triangle because the a squared plus the b squared did equal the c squared. So we'd call this one then a right triangle because the Pythagorean theorem worked. Okie doke. So let's try this one here. I'm going to go ahead and get you started. If I look at the three sides, I'm trying to figure out which one's the longest. I think the 18, well, definitely longer than 13, and this would not get that big. So this is like assumed to be maybe the right angle. So 18 is my C value. So I'm going to go 13 squared plus 3 root 3 squared equals 18 squared. Okay, now I want you to clean that one up, and I want you to write this right here, this piece right here. I want you to get rid of that radical. I want you to square it, and I want you to write this piece right here, and then see if you can find the correct answer in the Ed puzzle. All right, 13 squared is 169 plus. Now, hopefully you got this one right. This is the tricky part. If you square 3, you get 9. And square the square root, those just cancel. So you're left with this 3. So you have a 9 times a 3. That's 27. Did you get 27? Equals 18 squared. I don't know that off the top of my head. I should. 324. Okay, so then why don't you now answer in the Ed puzzle, do you think that this is a right triangle? All right, hopefully you said no, that's not even close to a right triangle. All right, so now let's talk about what do they mean by acute or obtuse. It all has to do with this supposed right angle. If you think of a right triangle, and that's the one that works perfectly, it's a right angle right there. However, if that angle were to open up and actually be an obtuse angle, what do you think is going to happen to that hypotenuse there for that to open up? Okay, that hypotenuse is going to get too long. In fact, it's not even going to be called a hypotenuse anymore because it's not a right triangle, but it would be too long. As that angle opens up, it's going to force your hypotenuse to be too big. So an obtuse angle, the hypotenuse is too big. If your hypotenuse is too small, that's going to be an acute triangle. And it's kind of like the three little bears. And if the hypotenuse is just right, then it's a right triangle. Okay, so let's look at this example. If you add the 169 and the 27, you add those together, that's 196. Compared to, and I guess all along, sorry, I should have question marks here, right? Because we're not really sure if it equals that. And we actually have specifically found that it does not equal that. You could put a big slash through it. And when you look at it, the c squared, over here, the c squared, the hypotenuse part, is too big. And if the hypotenuse is too big, then we have ourselves an obtuse triangle. So you'd say this one is obtuse. All right, so now you practice that. Okay, so let's start off with this one. I'm going to get you started, and then I'll turn you loose. When I look at the three sides, I've got a 7. 12 is definitely bigger than that. Square root of 95, well, if it was the square root of 100, it would only be 10. So the 12 is going to have to be the longest. So you're going to treat this as your C and see if the Pythagorean theorem works on that. All right. And then once you've done the Pythagorean theorem on it, you decide if it works, you'd say it's right. If the C value is too big, it's obtuse. If the C value is too small, it's acute. You decide which it is. I got it to equal out, did you? It's a right triangle because 144 does equal 144. All right, so take a look at the next one. Let's decide what the A and the B and the C are. So you got a 6 and a 7, and then you have the square root of 61. I always kind of estimate what I think this would be. If that was a 64, the square root of 64 is 8. It's just a little bit less than 8. So I think that's going to be the assumed hypotenuse. So then let's run this through. If this is going to be my C, the square root of 69 or 61 is my C, go do your Pythagorean theorem, decide if it's right, acute, or obtuse. Again, if it works, it's right. If your C is too big, it's obtuse. If your C is too little, it's acute. I got this one to be acute. The 61 that I'm getting from the C squared over here, that's too small compared to the other two legs. If the hypotenuse piece is too short, then it's got to be a acute triangle. All right, what do you think? Could you do these problems for your test? All right, why don't you move on to special right triangles?